To reduce the length of the video, we divide this problem, that is a problem of transportation problem, or this is an exceptional type of transportation problem. This is maximization type, this is unbalanced, there be a degeneracy. Okay, so this is a lengthy problem, so we divide into a two part. This is the part B, and continuing to part A, we already find out the initial basic feasible solution by using Vogel approximation method. Okay, we start from this position. Now to check the optimality, here we use UV method. Okay, now what is UV method? To understand UV method, we practically say how the method used here. Here we write first UI in the place of AI, and here we write Vj. Okay, now we find out the row or column which have maximum number of allocation, not maximum amount of allocation, maximum number of allocation. That is, in the first row there will be a 3 number of allocation, in the second row there will be 1 number of allocation, in the third row there will be 3 number of allocation, and here also 3 number of allocation. And we choose any one of the maximum number of allocation, either row or column. We choose UI or Vj in this row or this column with 0. Okay, we take here we take this is 0. Okay, this column, this is V1, this is 0. And since this is 0, and here we use two formula for allocating cell. Allocating cell, that is basic cell. Basic cell, we use the formula Cij, this is Ui plus Bj. And for non-allocating cell, or non-basic cell, we use the formula Dij, this is given by Cij minus Ui plus Vj, and this is also known as Zij minus Cij. Okay, this is the form of Zj minus Cj, that is net evaluation or cell evaluation as LPP in simplex method. Okay, now since these three are allocating cell, so we use the first formula Cij, this is equal to Ui plus Vj. Here Vj, that is V1 is 0 and this is 4, so we must take this is 4. Similarly, this is 0, so we must take it is also 0, because 0 plus 0, this is equal to 0 for allocating cell. This is also allocating cell, so we take here 6, because 6 plus 0, this is 0. Now we get this is a allocating cell, here is 4, so we must take this is 7, because 7 plus 4, this is equal to 11. Cij, this is equal to Ui plus Vj. This is 22, so we take here 18, because 18 plus 4, this is equal to 22. This is given by 6 and this is given by must be 6 minus 6, because 6 plus minus 6, this is equal to 0 for allocating cell. So we get all the Ui or Vj. Okay, now we find out all of Dij for non-allocating cell. Here we get a non-allocating cell, this is remaining, so we put this is equal to 0, because this is 6 we already get, and this is allocating cell, so we get this is 0, because 0 plus 6, this is equal to 0. So we get this is V1, V2, V3, V4, V5, and this is U1, U2, U3. Now we find out Dij. For this cell, we first find U1 plus V2. This is 4 plus 0, and Dij is equal to Cij minus Ui plus Vj. So 19 minus 4 plus 0, this is 15. We put it in a circle in the middle. And clearly this is non-allocating, so we get 0, this is Cij, minus 4 minus 6, okay, 0 minus 4 minus 6, this is clearly 2, and we put this is in the circle. Here in non-allocating cell, this is 0, this is 0, so we get 9 minus 0 plus 0, this is 9, and this is 18, this is 0, so 14 minus 18 plus 0, this is minus 4. Here 7, here 0, so 14 minus 7, so we get 7. Here 18 and here 6, so 16 minus 18 plus 6, we get minus 8. Okay, and here 7, here 6, and 11 minus 13, so minus 2. Here we get 3 negative values. Dij all are not greater than equal to 0. So we cannot reach at the optimal position. Okay. So here we write, since sum Dij less than 0, so this basic feasible solution is not optimal. Okay. Now it requires some improvement. To improve this type of solution, we must draw a loop. Okay. So we draw a loop to get improved solution. How to draw a loop? We first make a table together with only allocation, okay, and indicating the most negative Dij, that is most negative net valuation. This cell, this is the most negative cell, so we write in a table, same type of table, but there I write only the allocation and we indicate by a dot only the most negative net valuation. We draw a table to form a loop. This is the most negative position of net valuation. This is minus 8. Now we draw a loop like this from this cell to this cell, and we go from this cell to upper cell and again from here and to here. Okay, and most negative net valuation means there we get a sum allocation. Okay, so we allocate here by loop, and for the process of allocation we write here plus theta, this is minus theta, this is also plus theta, and this is minus theta, because the amount of allocation be constant. This is not changed, so we get plus minus, and we choose theta. This is equal to mean of minus position, that is the position of epsilon and 60 and epsilon. Clearly the epsilon is the minimum value of 60 and epsilon, because epsilon is greater than 0 but a small number, so we get epsilon and we get the new table or new table with new allocation as we write here. We draw the table as like this. There be 3 row and 5 column. 5 column, right? And the allocation are there be 10, because 10 plus epsilon, this is equal to 10. We already say that epsilon is greater than 0 with xij plus minus epsilon, this is xij also. Okay, so this is 10, this is also 60, this is 30, this is also 30, and this cell is vacant now, because epsilon minus epsilon, this is vacant 0, and this is 20, and this is again epsilon. Okay, this is becomes allocating cell, and this is 50. So here also the number of allocation is 6, 6 and 1, 7. So the number of allocation is not changed, 7 number of allocation. And now we write in this table again the cost coefficient. This is 4, this is 19, this is 22, this is 11, 0, 0, 9, 14, 14, 0, this is 6, 6, 16, 11, 0. Okay, again we find out the value of ui and vj. Here we write ui and here we write vj. Okay, and the number of maximum number of allocation, here we take in the first row because maximum number of allocation is here and here. We take here the first row. Okay, then by the same argument, using the result Cij, this is equal to ui plus vj for the allocating cell, we get this is 4, this is 22, this is 11. Okay, and getting this side is, this is 22, so this must be 6 minus 6, because 22 minus 6, this is equal to 16. Here the cost is 16. Here minus 6, so we get this is 12 because 6 is here. And this is 6, so we must get this is 6. Now since this is 4 and this is allocating cell, so the cost 0 is getting by taking minus 4. Okay, so we find out all of Dij for the non-allocating cell. How to find out Dij? For this cell, this is 19 minus 12 plus 0. So this is 7, this is positive. Here this is 0 minus 0 plus 6. This is minus 6, this is negative. This is 9 minus 12 minus 4. This is 1. Okay. This is 14 minus 22 minus 4. This is minus 4. This is 14 minus 11 minus 4. So this is given by minus 1. Okay, because 14 minus 11, this is 3 and 3, sorry, this is not minus 1, this is 7, because 14 minus 11 minus 4, this is 14 minus 7, this is 7 here. Okay, and here this is minus 2. Here this is 11 minus 6, this is 6. Okay, so we get again 3 negative Dij. Here also one cell remains, this is 6 minus 4 minus 6. So we get, this is given by 6 and 2, this is 8. This is positive. Here we get 3 negative Dij. Okay. To resolve the negative net evaluation, we again make a table to form a loop. Here we indicate the most negative Dij, this is minus 6. Now we form a loop like this. This is of type this. Okay. And we again write this is plus theta, this is minus theta, this is plus theta, this is minus theta. Okay, and we may here indicate the direction. Here theta, this is mean of 50 and 60, because we already say theta is minimum of minus theta cell, that is 50 and 60. So this is must be 50, and we get the new table with new allocation as. This is the new table with 3 row and 5 column. This, and the new allocation is, here allocation is 50 because plus theta here. Here this cell is empty because 50 minus 50. Here epsilon plus 50, this is 50. Okay, and here 60 minus 50, so here we allocate 10. This is remains same because it is not in the loop, and again this is 10, this is 30, this is also 20. Here also the number of allocation is 4 and 3, 7. Now we write the cost coefficient again, that is 4, 19, here we write 4, 19, 22, 11, 0, 0, 9, 14, 14, 0, this is 6, 6, 16, 11, 6. Again we find out ui and vj. Okay, and here we take this ui is 0 because here number of allocation is 4. So vj are, this is 0, 11, 22, this is 4, using the allocating cell law. Okay, now it is clear that this is 16 and this is 22, this is allocating cell, so we get this is minus 8. Okay, and since this is 6 and this is minus 8, so this is given by 40, and since this is 4 and this is 0, so we get minus 4. Now we calculate again Dij. How to calculate Dij for this cell? This is 14 plus 0, 19 minus 14, this is 5. And for this cell, this is 9 minus 10, this is minus 1. This is 6 minus minus 4, this is 10. This is 14 minus, this is 18, so minus 4 here. This is 11 minus 8, so this is plus 8. This is 6 plus 8, this is 14, and for this cell this is 4. Okay, here also we get 2 negative here and here, so we must have to form another loop starting with this cell. Okay, that is the cell with most negative cell. So we make another table to form a loop. Here we write in this table only the allocation and indicate here by a dot only the most negative cell. This is minus 4. Now we form a loop starting from this cell, and the loop is like this. Okay, here again we write plus theta, minus theta, plus theta, minus theta, and indicating by arrow. Okay, and here we choose theta. This is mean of, this is minus theta and this is also minus theta, that is 30 and 10, so this is 10. Okay, and we get the new table as, this is the new table. Now here we put the value of theta, this is equal to 10, we get this is allocating cell, this is 10 unit allocation. Here this is empty cell because 10 minus 10, this cell becomes allocating, and this is 20 unit, this is again 20 unit because 30 minus 10, and all the remaining cell are same, 20, this is 50, and this is 30, this is 50. Okay, so this is allocating cell, this is 20, this is 20, and this is empty. Now here the number of allocation again 3, 5, 7, and here in this row the number of allocation is maximum, so we here again write ui, this is equal to 0, and here vj. Now we write all the cost coefficient, this is 4, 19, 22, 11 0 0 9 14 14 0 6 6 16 11 6. Okay, now we get in similar manner as above. We already done UIVJ in several cases. This is 4, this is 11, this is 0. And since this is 4, so we must write here minus 4. Since this is minus 4, so we must write here this is 18. And this is 18, so we must write here 2. Now we find out Dij. Sorry, this is minus 2, so this is 8. Okay, now we find out Dij for this cell. This is non-allocating, so 19 minus 8 plus 0, this is 11. This is positive. This is 22 minus 18, so this is 4 because this is 0. This is 9 minus 8 plus minus 4, so this is 5. This is 14 minus, this is 7, so this is 7. This is given by 4, this is given by 8, this is given by 2, and this is given by also 4. So we write here all of Dij greater equal to 0. So optimal solution, optimal condition satisfied, and optimal solution is we write optimal solution. This is x11, this is equal to 20 unit. This is x14, this is equal to 11 unit. We cannot write this because this is in the dummy column. Okay, this allocation has no physical existence. Okay, and we write x21, this is 20 unit, and x23, this is 10 unit, and x32, this is 20, and x33, this is 50. Okay, now here be an important question, how to find the maximum profit, because this problem is of maximization problem. To find the maximum profit, we must write here, or we must take the original cost. Here we write max profit. Max profit. Max profit is given by, we get this is 20 into the original cost of one cell. This is given by, this is the original table, 40, plus this is 30 into original cost is given by 1 2 3 4 cell. This is 33, plus, and this is 20 into original cost is 44, plus this is 10 into original cost is 30, plus, and this is 20, original cost is given by, this is 38, plus 50 into original cost is given by 28. Okay, now calculating this result, we write the mean cost. This is 5130 unit. Okay, this is the not mean cost, this is the max profit, and this is the solution of the problem. This is very important problem, and there will be several type of exception in this transportation problem. Okay, thank you for watching.